Hello all, and welcome back to the home of hard science. So today we have to roll up our sleeves and deal with this latest fiasco around erythritol, the sweetener which apparently causes heart attacks. So I'm going to decode that for you really quickly. I reviewed the paper. But first, a word from one of my favorite actors, Christoph Waltz.
Ooh, that's a bingo.
Well said, Christoph. And you guys have all heard about kind of buzzword bingo. Well, we're going to do BS Science bingo. And it doesn't actually take very long running through a paper to find the logical problems within it that really make it clear whether it's something you can depend upon or not. And please do share this very brief analysis with people to help them understand and clarify the reality around this erythritol scare that's hit all the media all around the world simultaneously. The coverage is astonishing, just like the TMAO one a few years ago, and I'm going to be mentioning that too. So let's get into it. So here we are. Here's the study in Nature Medicine. And erythritol causing heart attacks and huge risk. Interesting. So let's dive inside. Note that Stanley L. Hazen is the key author. And note that it's from Cleveland Clinic. And this will become very relevant shortly. So here it is, and here's one of the main graphics, and you can see the people who are higher, the highest quarter of people in blood levels of erythritol had a lower survival rate, i.e. they had more heart attacks. And this cohort was European in the study, and it was average age 62 of people who were kind of sugar-sozzled heart disease people, broadly speaking. But you can see the top quartile of erythritol in the blood, they had a high hazard ratio, up around 4 and a bit, right? So that's a pretty high risk ratio. And then they looked as well at keto-friendly prepared foods and beverages, so you can get an idea of what they're going after here. And they look at what happens if you feed yourself with erythritol. How high does your blood level go? And what they saw was, wow, the first few days after taking a drink with erythritol, quite a lot of it, you went up to around 6,000 or 7,000 micromoles, right? Very high levels indeed. But note the first bingo item. The low cardiovascular disease people were around 4 micromole in their blood, and they had relatively low heart disease. The high CVD quartile were around 6 micromole in their blood, and they had much higher. We said a hazard ratio of around 4. But if you drink erythritol, you go up to 7,000 for a few days, and this will become very relevant shortly. Bingo time. Let's move on. So, if we look closer at the US cohort, where they looked 5 years ago at the blood levels of erythritol, we see that there was around a 2.6 or so hazard ratio for the highest people for heart disease. But their European cohort, there was a much higher hazard ratio for these heart disease people for the erythritol in their blood. It was up at 4 point something, maybe heading towards 5. That's interesting. And the reason is, I would suggest, is the European cohort were 72 average age, whereas the US were 62. So these guys in Europe were older and more metabolically sick. And as a result, the hazard ratio for erythritol showed up as higher. Now, this is something I noted, and I said, I wonder what happens when they correct for their other cardiovascular and sugar-sozzled risk factors and take that out of the equation. And what happened was, for the US guys, they went down to around 2 hazard ratio, dropped right down. And when they corrected the European guys for other cardiovascular risk stuff, they dropped down to around 2. So now the big difference dropped out, and they were both around hazard ratio of 2. And this is an interesting tell or a show in the study. It indicates that the problems these guys had were less to do with the actual erythritol and more to do with their terrible metabolic health. So we'll go on to the other show or tell. I mentioned that postprandial or after meal erythritol levels in the plasma shot up to 6,000 or 7,000 micromole after taking the erythritol drink. That's a massive number. And you noticed, I hope, that the low and even the high coronary vascular disease people in the associational study were 4 to 6 micromole. Now, what this means, I would say, is these people were sampled 5 years ago before erythritol really hit the market. So I was questioning how 62 or 72-year-old people were on keto-friendly erythritol-type sweetener diets, right? Made no sense. But even better, we can see now there's no way that these guys were consuming erythritol worth a toss back 5 years ago, because their blood levels would have shown up if they were. At least a whole series of them would have shown up with super high levels, but they didn't. So you can basically infer from this that the results from the associational study had nothing to do with consumed erythritol. And then you would think it's more to do with erythritol in their blood from endogenous or internally fabricated processes, which may relate to heart disease. Now we're getting somewhere. Now we're getting into a bit of bingo. So I think that's all you need to see that this is hype, but it is important to note why they got these results and what's really going on under the hood. So we'll go through that now. Indeed, the why is an important question. You've got to answer everything. So, not too complex. Erythritol is a pentose phosphate pathway metabolite in the body, and it's associated with adiposity gain in young adults and diabetes and heart disease and all that stuff, of course, over time. So endogenously produced erythritol is a signal for heart disease and other problems. And how do you make your erythritol in your blood if you're not eating erythritol? How do you make your blood level go up? Well, that's simple. You just eat plenty of this, because this results, this pathway, largely from metabolizing glucose and sugar. So now we finally squared the circle, and we know what this study was about. But didn't I mention at the start that we got to keep an eye on this Hazen guy and the fact that it was Cleveland Clinic? Why did I say that? Well, I'll explain. Because several years ago, there was a TMAO scare. The TMAO, LMAO, as we laughed about it. And what I found back then, very quickly, was the TMAO thing was nonsense, because it was endogenous TMAO produced in the body through various processes for diabetic and kidney disease and cardiac disease people that gave the association. It was not the TMAO that was consumed. So it looks like just like erythritol. So this crew have form. And I'm going to show you a brief clip now when I was on Dave Feldman's Cholesterol Science show in a debate with Joel Kahn. And I briefly went through the story with the TMAO scam. I mean, I can't think of a better word, and it sounds harsh, but scam. So here you go. TMAO, I know, is being talked a lot about. I went and researched it briefly around a year or two ago because I heard it coming up, and I judged that it wasn't worth my time. I'm too busy to waste time with stuff like this. But I spent 20 minutes yesterday checking it out again because it's topical. And on the top left, you'll see I quickly found that kidney disease people have very high TMAO. But when you transplant kidneys into them, their TMAO rockets back down to the level of healthy control people. In other words, I don't have time to get into it. I think TMAO is a marker, among other things, for chronic kidney disease or low glomerular filtration rate. And kidney problems, along with diabetes, are the greatest reason for atherosclerosis and calcification in the world. And here we see that these types of problems higher your TMAO, and they're going to gift it a great correlation. So that's just crazy for a start. And they're correlated with all the inflammatory markers too that are due to kidney disease or hyperinsulinemia, blah, blah, blah. And there you are. Doesn't take a whole lot to debunk these kind of obfuscators and outfits that go after meat and go after whatever it suits them to go after. It just requires basic logic often and doesn't even require a lot of math or complex modeling or calculations. Hopefully, as I've illustrated, this does not demonstrate that erythritol has no harm. All of the data to date suggests it doesn't at all, but this debunking, if you will, does not prove that it is not harmful in some manner. But what it does do is show you that it provides no basis logically or scientifically or in any degree of confidence that erythritol is indeed bad. So maybe erythritol's bad, but we're right back to where we were before this study came out and exploded across the media. So that's it, folks. Hope you enjoyed this clarification. And please do, if you did, comment below, have the discussion, and hit subscribe button, and also hit that little notification bell, and share, of course, because this one particularly has gone everywhere. And unless people understand the basics and the logic and what's actually in the paper, we'll have more misinformation and disinformation. On that point, thanks so much to my Patreon supporters and PayPal. I've been countering misinformation and disinformation for many years now, but it's kind of a full-time job, and I really appreciate the support and anyone else who can jump in and support a little. Thank you so much.